So today we're going to talk a little bit about Darwin, and specifically this lecture is going to be called Descent with Modification, a Darwinian View of Life. So I think the first thing most people think about when they hear about Darwin or what he did is evolution, and that certainly was kind of a new way of thinking that he brought into kind of the scientific community and the world for that matter. So we're going to talk about Darwin as well as some of the researchers that came before him, and we're going to see and kind of compare what all their opinions were on this topic. The first scientist we're going to talk about is Aristotle, and I think most people have probably heard of Aristotle, but he was around about 384 to 322 BC. And Aristotle was a Greek philosopher who kind of viewed species as being fixed and unchanging. They're the way they are now, they've always been that way, and he kind of thought that they were always going to be that way from that point on. And the way he also kind of described species and their relationship to one another was that they could kind of be arranged on a ladder or a scale of increasing complexity. And he called this scala naturae. And so the way I kind of look at it is you have a ladder, and maybe on top of the ladder you likely have a human, right? We're kind of the most complex, the most intelligent animals. Maybe on the next step down you have something like a chimpanzee. The next step down maybe you have a dolphin or a bear or something like that. And then if you work your way down to the very bottom of the ladder, you would probably have something like a unicellular protist or a slime mold or something that we would think of as not being very complex and not very intelligent. So this is kind of how Aristotle viewed species and viewed living organisms on the earth. He saw each individual form of life as perfect and permanent. Each had its allotted rung on the ladder, and each would always maintain that kind of physiology or that kind of being and intelligence. And obviously when you talk about evolution, you kind of have a lot of conflict between religion and science. And so I'm just here to kind of give you the facts of what all these people believed. And Aristotle believed that these ideas coincided with the Old Testament, and that all these species were individually designed by God and were perfect. The next individual we're going to talk about is Carolus Linnaeus. And Linnaeus was a really cool scientist who developed the branch of biology known as taxonomy. And Linnaeus was a Swedish physician and botanist who sought to classify all of the diversity or all of the biodiversity we find on life for the greater glory of God. So he liked to kind of group animals, put them in certain classes or certain orders. He liked to categorize them. And he came up with this branch of biology called taxonomy, which we still deal with quite a bit today. And he is the one responsible for developing the two-part or binomial system of naming organisms. So, for example, we often refer to an animal as a genus or a species. For example, humans or Homo sapiens. So we can thank Linnaeus for that kind of contribution. Linnaeus also used a nested classification system which grouped similar species into increasingly general categories. And he made the observation that some species resemble each other, but that didn't necessarily imply evolutionary kinship. Rather, he kind of interpreted it as a pattern of creation. So again, this is just an illustration of Linnaeus, the founder of taxonomy, and we get our binomial naming system from him. Another thing I always like to point out is you guys, if you've taken a biology class before, have heard of kingdom, phylum, class, order, family, genus, species, right? As humans, we like to categorize things. So he was the first person to do this. Now, the third individual we're going to talk about is named Georges Cuvier, and he was a French scientist that was around from 1769 to 1832, and he kind of developed the study of paleontology, which, again, I think everybody's probably familiar with paleontology, and we all like to watch movies like Jurassic Park where people study fossils or or maybe study dinosaurs and cool stuff like that. So Cuvier was kind of the first person to do that. But let's give a definition to fossils. We all know what they are, but specifically, fossils are remains of traces of organisms from the past. Many fossils are found in a type of rock called sedimentary rock. And sedimentary rocks are basically formed from the sand and mud that tend to settle on the bottoms of different types of bodies of water like seas and lakes, different types of wetlands like marshes. And over time, they're going to get covered and compressed into layers of rock that we call strata. So this is a great example of different layers of strata that we can see. It says here, fossils from the strata of sedimentary rock in the Grand Canyon. We can see on the top there's an illustration of a fern fossil that they found in kind of the shallower regions of a strata they call the Hermit Shale layer. And that fossil's about 265 million years old. On the bottom, you see an illustration of a trilobite fossil. Those are pretty cool little creatures. And this is found deeper in the layer of sedimentary rock from an age they call the Bright Angel Shale layer, which is older, about 530 million years old. Now, specifically to do his research, Cuvier examined rock layers around Paris and observed that the deeper the rock was, the older the strata was, the more dissimilar the fossils were from those layers that were, closer to the top or from current life. So he observed that from one strata to the next, some new species appeared while others tended to disappear. So he was seeing, kind of a difference in organisms when you went from, layers of rock that were closer to the surface to layers of rock that tended to be deeper in the earth. He denied that species ever evolved, and he opposed this idea of gradual evolutionary change, but supported something that he called catastrophism. So, giving a specific definition to catastrophism, it says that it speculates that each boundary between strata represents a catastrophe, such as a flood or a drought, that destroyed many of the species living at that time. So George Cuvier basically said, okay, I see that there's a difference between these layers. The species are changing. They're a little bit different, but what caused that? He didn't contribute it to evolution per se. What he kind of hypothesized was that, maybe the animals that were at the bottom, something happened. Maybe there was a drought that killed all those animals and they died. Over time, we had sediment compress those individuals and new animals came around. Okay, maybe something else happened that killed those, and then so on and so forth. So he kind of called this idea catastrophism.